Hi, now we're going to do some factoring of perfect squares, or into perfect squares. So this is another one of those special cases. So we want to remember what a perfect square is. So a perfect square is like the number 25. So 25 is a perfect square, and that's because it is 5 times 5, and these guys here are the same factor. So if we are factoring with perfect squares, then that means that we have two of the same factors. That means that something actually was a perfect square. So now this we can write as something squared, but I'm about to multiply it out, and I can't multiply out something squared. I do have to write it twice, and now I'm going to FOIL it out. So there's my x squared plus 5x plus another 5x plus 25. Combine these like terms, and I have x squared plus 10x plus 25. So really, what we would do is start with this. So there is x squared plus 10x plus 25. So here is our trinomial, and we would want to know, how can I check to see if that is a perfect square? Well, first of all, it's a trinomial. So this guy here, can you just factor it the other way? Two sets of parentheses, multiply to 25, add to 10? Yeah, you can. But here's another little way if you want to look for some kind of little, oops, that's if we were doing it the other way, some kind of little shortcut. I don't even know if it's a shortcut for some of the other ones. It might be, maybe not this one. If you see a square here, a perfect square, perfect, P-E-R-F-E-C-T, square. Can't talk and spell at the same time. In the front and in the back. So it's a trinomial, and the first and third terms are perfect squares. Then what we would do is take the square root of the first and last terms. So that's half of your power, it's x. Square root is 5. You would multiply these guys together, and you would get 5x. If you can double that term times 2, so 5 times 2 is 10, if when you double that you get this middle guy, then you can factor this using your perfect square method, and the factor would look like x plus 5 squared, and that's what we had over here. We can see that. So we can say that this is going to be x plus 5 squared. And that's how this guy factors. And we know, we multiplied it out, and this is how it's going to factor, but this is our little check to see if it's a perfect square. Let's try again. I know the first couple times a little iffy. So what we would do here, here's trinomial. Take your first and last terms that are perfect square, square root, 4. Multiply them times each other, 4x. And then, so here we want to multiply M-U-L-T, and then you want to double it. And when you double the coefficient, remember, the x times 2 is 2x, so you multiply the coefficient here, and then we get 8. So yes, it is a perfect square, and then this would factor into x plus 4 squared. This guy over here, let's try him. Square root, and of course I see they're both perfect squares, so I can x and 9. If I multiply these times each other, I do get 9x. When I double 9x, 9 times 2 is 18, so yes, this is a perfect square. When I go to write my answer, it's going to be x minus 9. It has to be a squared term. But let's double check this. We saw 1 multiplied out before. Let's multiply this guy out and just make sure we kind of see how it all works. Well, x minus 9, remember, when you square it, you have to write it twice. X minus 9 times x minus 9. Okay, so let's multiply. Double distributing. X times x. X times a negative 9. Negative times a positive, 9x. Negative times a negative is positive 81. Combine these terms in the middle, and that is how we got that. Negative 18x plus 81. So yeah, that's how it's going to work. So, things that we want to recognize here. Yes, the first and last terms are both squares. It doesn't matter if this is a plus or minus for your middle term. That's going to be the sign that you use in your factor. But that last term has to be positive. Has to be positive because when we multiply out, that negative 9 times the negative 9 is a positive 81. And we saw farther up here, we did a 5 times 5, positive, and we did get a positive 25. So there's your plus 25. Did that plus disappear? I don't know, I hope not. So plus 25. So always positive, can be either sign. So let's take a look at this next one. For this next one here, let's see. Here, that's a perfect square, that's a perfect square. So let's try it. It's x, and that's 6, multiply and double, and it works. So x plus 6 squared is how I'm going to factor that. Now, all of the ones that we have done so far, we could have done previously, but number 5 is a little bit challenging because we threw in a leading coefficient and extra variables, because why not? But perfect square in the front, perfect square in the back. Let's go for it. So I'm going to take the square root of each of these. So that's the square root of the number and half of that. Square root of our number, half of that. Multiply them times each other. Multiply in here. I'm going to get 6ab. 2 times 3 is 6, and then ab. Double it. When I double, I just double the number, and yeah, it works. Because I get 12. 6 times 2 is 12, ab. So 2a minus 3b squared is my final answer. And that's how that would be factored. So now let's go on to some ridiculousness down here with number 6, and let's check it out. Perfect square, perfect square. I can tell the numbers are perfect squares. I recognize them. And the variables are raised to even powers. Square root, square root. 5a, 6b squared. If I multiply these guys times each other, 5 times 6, well, that's 30. A, b squared. Write them next to each other. And now I want to double it. If I double it, and I get this, and I do, 3 times 2 is 60, and my variables are the same, well, now I know that that is a perfect square, and my answer is 5a plus 6b squared squared. Looks like this. Five a plus 6b squared, all in parentheses, and squared again. Last one. Let's check out number 7. I wish I had a red pen here. Okay, so now for this guy here, this is kind of important because we want to notice the first and last guys here. Those are perfect squares, so let's give it a go. And that's going to give me x, and that's going to give me 6. Multiply them together, and I get 6x. And now I'm going to try and double it, and 6 times 2, 12. It's not 13. And actually, this problem, very similar to number 4, maybe some of you already recognize that, and all the same except for the 12 actually worked. So it was x plus 6 squared. This one doesn't work. But that doesn't mean you can't factor it. It means that it's not a perfect square. So I am going to not factor that using the perfect square method. Now, if it didn't work for this guy, I would quit because this would be a ridiculous thing to try to factor some other way. But this is a simple trinomial. So let's kind of rewrite that guy as x squared plus 13x plus 36. And let's factor it the way that we did a week or two ago, and that's with two sets of parentheses, x in the beginning of each, multiply to 36, and add to 13. So we want two numbers that will multiply to give us 36 and add to give us 13. Well, it's not coming to you. 2 and 18, 3 and 12, 4 and 9, and 6 and 6. By the way, there's your 6 and 6. That's what this one is if you wrote it twice. But here's our 13. So it's x plus 4 and x plus 9. That's how this guy is going to be factored. So he can be factored. It's just not a perfect square. So just know when this method doesn't work, it tells you it's not a perfect square. And for the simpler ones, I would try another way. Hopefully that helped. Talk to you soon.